Welcome to IT.Solution, your total network, system, firewall, and security partner.
Welcome to this explainer covering ITN Module 5 on number systems. Today, we're going to unlock the absolute foundational math of networking. Think of this as your secret translation guide, literally the ultimate Rosetta Stone that bridges the gap between how we, as humans, understand information and how the machines that actually run the internet process it. If you want to truly master networking, you've got to learn to speak the language of the equipment. So let's jump right in.
It's kind of fascinating to think about, right? Because at this very moment, there is a massive communication gap between our human world of numbers and the machine world of routers and switches. We count using our 10 fingers, but the devices routing all this data across the globe right now, well, they operate entirely on electrical impulses, essentially just microscopic on and off switches. So how exactly do we bridge that gap?
Here is our roadmap to unlock these languages. First, the language of computers. Second, binary and IPv4 basics. Third, binary conversion steps. Fourth, hexadecimal and IPv6. And finally, mastering hex conversions. We'll break this down into easy, logical steps.
Okay, let's dive into this. Section 1, the language of computers, bridging the communication gap.
Essentially, we're learning to be fluent translators between three very distinct languages here. First up, we have base 10, or decimal. This is the human language we use every single day, using digits 0 through 9. Then we have base 2, or binary. This is the computer's native tongue, using strictly ones and zeros, which we call bits. And finally, we have base 16, or hexadecimal. Think of this as the networking shorthand, utilizing numbers 0 through 9 and letters A through F. To understand how data is routed globally, we need to translate seamlessly between these three.
Moving right along to Section 2, binary and IPv4 basics, the ones and zeros of the web.
So what exactly is it? The formal definition of the binary numbering system is a base 2 system consisting entirely of ones and zeros. These are called bits, and this is the exact literal format that hosts, servers, and network equipment use to identify one another. To tie this back to the real world, this is exactly what the home router sitting in your living room is thinking in right now. It doesn't see web pages, it just sees a constant rapid-fire stream of ones and zeros.
And this brilliantly illustrates how that works in practice. Take a familiar IPv4 address, like 192.168.10.10. To us humans, it's 4 readable decimal numbers separated by dots. Easy enough, right? But look underneath that. Each of those decimal numbers is actually an 8-bit binary string, which we call an octet. A standard IPv4 address is really just a 32-bit string of binary chunks. That dotted decimal format we all know, it's just a convenience for our human brain.
Which brings us to Section 3, binary conversion steps. Let's decode the matrix.
Listen, if you take away just one single thing from this explainer to help you with subnetting and IP addressing, it absolutely needs to be this positional value chart. It's your ultimate cheat sheet. Because binary is a base 2 system, which is our radix here, each position from right to left represents a power of 2. You absolutely need to memorize these positional values from left to right. 128, 64, 32, 16, 8, 4, 2, and 1.
With that cheat sheet in your head, converting a decimal number to binary is incredibly straightforward. Just treat it like a simple recipe. Step 1. You always start at the left, at that 128 positional value, the most significant bit. Step 2. You ask yourself, is my decimal number equal to or greater than this positional value? Step 3. If yes, write down a 1, subtract that value from your decimal number, and take the remainder to the next position. If no, just write a 0 and move on. Step 4. You just repeat this sequentially all the way down to the 1 positional value.
So the real secret here is that this whole conversion process is literally just simple addition and subtraction. You take your number, you check if it's greater than or equal to 128. If yes, you add a 1 to your binary string and subtract 128. If no, you add a 0. Then you just cascade down the line through 64, 32, and so on. It perfectly bridges the gap between base 10 and base 2 without any complex math.
Let's shift gears a bit. Section 4, hexadecimal and IPv6. The big upgrade.
Now, as brilliant as IPv4 is, our network growth absolutely exploded over the last few decades. We simply ran out of 32-bit IPv4 address space. So the massive upgrade is IPv6, and the magic number here is 128.
IPv6 addresses are a staggering 128 bits long. Can you imagine trying to write out a single IP address that consists of 128 ones and zeros? You'd literally get carpal tunnel just configuring one router. It would be an absolute unreadable nightmare for humans.
Let's see how this builds. To solve that massive readability problem of 128 bits, networking relies on hexadecimal. This elegantly compresses the address into a 32-character shorthand. An IPv6 address uses 32 hex values divided into 8 groups of 4, which we call hexdets, and they're separated by colons. It's the exact same data under the hood, just packed into a much more human-friendly format.
Now, what's really interesting about this is how perfectly hexadecimal aligns with binary on this Rosetta Stone chart. Every single hex digit, from 0 through F, perfectly represents exactly 4 binary bits. For example, a binary 0000 is a hex 0. A binary 1111 is a hex F. Because 16 is a power of 2, the translation between base 2 and base 16 is incredibly clean and mathematically beautiful.
All right, let's bring it all together. Section 5, Mastering Hex Conversions, Speaking the Shorthand.
Converting a decimal number to hex is super easy if you use binary as your bridge. It's all about chunking. Step 1. Use the skills we just learned to convert your decimal number into an 8-bit binary string. Step 2. Slice that 8-bit string right down the middle, giving you 2 groups of 4 bits. Step 3. Use that Rosetta Stone chart to convert each 4-bit group into its single hexadecimal digit. That's it.
Let's walk through a practical example with this, because seeing the math actually work out is so satisfying. Let's take the decimal number 168. First, we convert to binary using our cheat sheet chart, giving us 10101000. Now, slice it right in half. The first group is 1010. If we check our chart, 1010 equals the letter A. The second group is 1000. On the chart, 1000 equals 8. Smush them together, and the decimal 168 is written as A8 in hexadecimal. Boom! Fast, simple, and elegant.
And of course, you can run this entire translation guide in reverse to turn hex back into human-readable decimal. Step 1. Take your hex digits and expand them back out into 4-bit binary strings. Step 2. Push them together into a single 8-bit string. Step 3. Run your binary to decimal addition using your positional values chart. The binary serves as the perfect bridge in both directions.
So, are you ready to read the secret language of the internet? Because you now hold the foundational keys to decode the very architecture of modern networks. You can look at an IPv4 address, an IPv6 address, or even a MAC address and know exactly what the hardware is processing underneath. By mastering decimal, binary, and hexadecimal, you aren't just memorizing random facts, you're truly learning to speak the language of the equipment. The real question is, how will you use this to start building the networks of tomorrow? Thank you so much for joining this explainer, and keep learning.
Thank you for watching. See you in the next episode.